Hello, today we're going to be looking at three-dimensional figures and specifically looking at volume. So first it's important we define what volume actually is, and it's the measure of the amount of space inside a solid figure. Because we're talking about the amount of space, if you recall units from previous topics, if we were finding perimeter, you can recall, I'll just write it right here. If you remember perimeter, we would say that it was singular units because it was just distance. So we would say that that was just a single unit. For area, however, we were now talking about two-dimensional space, and really we were talking about how many blocks fit inside of an object, so that was units squared. Now for volume, because we're talking about how much space is inside, that's three-dimensional space. So we're now actually referring to how many cubes fit inside the object. And so our unit will always be units cubed. So just to kind of get that out of the way at the beginning, something to remember, anytime you're calculating volume, you're going to have units cubed. Okay, so we can ignore the surface area formulas here, but I want to just quickly go over the formulas that you see here for volume. So first, for the volume of a rectangular prism, you can see the rectangular prism right there, and we should probably name it. So let's go ahead and write that down. This first object is a rectangular prism. So for any prism, the main formula that you'll need to know is volume will equal the area of the base times the height. So in this one, as you can see here, the one that I highlighted in yellow, it says volume equals length times width times height. That's because the bottom of the base, or the area of the base, would be this rectangle down below. And the surface inside of there, its area would be length times width. Then, to add that third dimension for volume, we multiply by the height of the figure. The same thing is true with our next figure, which is a cylinder. So, cylinder's right here. Oops, sorry. And if we look at the formula for a cylinder, its volume is pi r squared times h, which again is just simply the area of the base times the height. So if you recall, we find the area of a circle by doing pi r squared. So when I look for my base here, my base is just going to be this bottom circle. And then my height, we can see, is the distance from the bottom base to the top base. So I would find pi r squared, the area of my base, and then multiply it by the height. So rectangular prisms, triangular prisms, cylinders will all use that same formula, area of the base times the height. That brings us then to pyramids. So I want you to look at the formula down here for the volume of a pyramid. And you'll notice it says 1/3 area of the base times the height. So that's just very similar to the other ones we've talked about. So this is a pyramid. Let's write that over here. And again, if you can find the area of the base, which I refer to as AOB, as you saw in the previous two formulas, and then multiply it by the height, the only difference is for a pyramid, it's 1/3 of that area of base times height. And if you were able to see the illustration done in class with the figures with the water, you could see that it took 3 whole pyramids to fill a rectangular prism that had the same base. So the base here is clearly a rectangular figure, so you would find the area of that. We can see the base right in here. You would find the area of that base and then multiply by the height. Now make sure when you're multiplying by the height, you're using the actual height of the figure, which is that center dimension, not a slant height. As we know, slant height will not be accurate. Okay, so now let's take a look at our last shape, because we're going to ignore the sphere for right now. Our last shape right here is a cone. And a cone is very similar to a pyramid. So you'll notice its formula for volume is right down here, 1/3 pi r squared h, which, if you think about it, the base is circular. So its area would be pi r squared, and then times the height, which is from the top vertex straight down to the base. So just like the others, we would say that the way to remember the volume will be 1/3 area of the base times the height. So I just want to point something out to you. I'm going to right now highlight in blue, or I'm going to outline in blue, all the formulas that you would be given on the quiz, but be then expected to know, or something similar, depending on which teacher you have, to these formulas that you will then need to know when you're taking the quiz. So now we're going to try a few, and we'll kind of keep these formulas in mind as we go. So let's look first at example 1. Now it's really important that we identify what the shape is first and foremost, and then we'll know how to quickly find the volume. So this one right here we can see is a rectangular prism. And if I were then to use my formula, I remember that volume is equal to the area of the base times the height. Because this is a rectangular prism, my base is a rectangle. Specifically, I can see that it's this 10 by 5 rectangle right there. Okay, so now when I go in to put my area of the base, I would just simply put 5 times 10, and then I multiply that by the height. I notice that the height over here of the whole prism is just 2. So I would end up with 50 times 2, which is 100 centimeters cubed. And that would be my volume of this figure. Okay, my next figure is clearly a pyramid, and we're asked to find the volume of this shape. So if I go back to, now notice it's rectangular base, so we'll call it a rectangular pyramid to be specific. And if I look back at the formulas, I can see that my volume formula is 1/3 times the area of the base times the height. So if I go back and identify my base here, it's this rectangular figure right here. And to find the area of a rectangle, it's just base times height. So keeping my formula all the same here, I would just write 1/3 times 4 times 10, because that's the area of my rectangle for the base, times the height of the whole pyramid, which was 6. So then I end up getting 40 times 6, which is going to be 1/3 of 240, which is a final answer of 80 centimeters cubed. Okay, on to the next example. Example 3. First, I identify the figure. This one is a triangular prism. Okay, now the one thing we do want to make sure we're careful of here is the base doesn't have to be laying down. So we would want to identify, in this case, the base of the figure as the triangle. So if you take a look, we'll highlight the base. And let's recall our formula for any prism is just volume is equal to area of the base times the height. So in this case, if our base is that triangle, even though it's laying on its side, we would say any area of a triangle is 1/2 the base of the triangle times the height of the triangle, which if you notice our base was 8 and our height was 3. And then we're multiplying that by the height of the figure, which in this case would be this surface laying down, which is 12. So we end up with 1/2 of 24 times 12, and 1/2 of 24 is 12. So then 12 times 12 gives us a final volume of 144 cubic centimeters. Okay, let's take a look at the next problem. In example 4, okay, it says Sam is filling the vase pictured below with water. After 2 minutes, the tank is up to 1/4 of its height. What is the unit rate in cubic centimeters per minute at which Sam is filling up the vase? So what we want to do here is, first of all, we want to be able to figure out the volume of the figure, and we want to know what the figure is. Well, clearly if it's a vase or cup or whatever it might be that's filling with water, this shape is a cylinder. So if we start by determining the volume, we remember that the volume of a cylinder is area of the base times the height. However, the area of our base is a circle, or the shape of our base is a circle, so we would do pi r squared. So that's going to be pi times 8 squared times the height of the whole thing, which is 15. So then the order in which you do this is up to you, but I recommend figuring out everything in terms of pi first. So we would have pi times 64 times 15. And then 64 times 15 is going to give us 960. And then when I multiply 960 by 3.14, I get 3,014.4, and that would be cubic centimeters. So we've got the problem started. Now remember, it's saying that after 2 minutes, the tank, the vase is filling up, but it's reaching 1/4 of its height. So we can imagine it's about right here when it's filled inside of there. So that's after 2 minutes time. So what we would now want to do is figure out, okay, well, if it's only 1/4 of the way filled, what amount of volume is filled at that point in time? So to do that, we would do 1/4 of the volume. So I'm going to do 1/4 times my volume, which was 3,014.4 cubic centimeters. And I end up getting 753.6 centimeters cubed. Okay, now that happened in 2 minutes time. If I want to turn this into a unit rate, I need to get it into 1 minute's time. So I would just take my denominator and my numerator and divide by 2 to give me a final answer that this vase is filling at a rate of 376.8 centimeters cubed per minute. And that would be my unit rate. Okay, last one we're going to take a look at today. It says find the volume of this figure. So this figure is actually made up of a cone on top of a small cylinder. So both the cone and the cylinder share a base, and the base is this circular piece right in the center. And so let's recall how we find first the volume of a cone, and then we'll talk about the volume of a cylinder. So volume of a cone is equal to 1/3 times the area of the base times the height of the cone. So the area of my base, because it's a circle and I know the radius is 3, would be pi times 3 squared. Then the height of just my cone is 13. So then from there, I would go ahead and say that 1/3 times 9 pi times 13 is going to be the volume of the cone. And then I see that 1/3 of 9 is easily just 3. And I know that 3 times 13 is 39. So really this is 39 pi. Now I'm going to leave it in terms of pi for now, and then we'll get a final answer at the end. But now let's take a look at the bottom part of this figure, which is a cylinder. So the cylinder portion of this we know volume of a cylinder is just the area of the base times the height. So the area of our base would be pi times r squared, which would be pi times 3 squared, times the height. Now if you notice on our figure, the height of this little cylinder was only 2. So this would end up being pi times 9 times 2, which is 18 pi. Now, because I want the total volume, I can take the two volumes of the cone and the cylinder and add them together. And when I do that, I'll get my answer of 57 pi. And then when I multiply 57 by 3.14, the value of pi, I would end up with a final answer of approximately 178, and then it ends up being 0.98, and this was centimeters cubed as a final answer.